This is a brief video of a laboratory demonstration of how waves can damage bridges. It's been developed by the University of South Alabama's Coastal Transportation Engineering Research and Education Center. During recent hurricanes, a number of bridges along the Gulf Coast of the United States have been damaged by the combination of storm surge and waves. This photograph of the US 90 bridge over Bay St. Louis after Hurricane Katrina indicates that the decks have moved off their pile caps in the direction of the wave movement. The University of South Alabama teamed up with Texas A&M to conduct some preliminary qualitative experiments in A&M's new large wave basin. A 1 to 15 scale bridge was built in the middle of the basin. 3 sections of the model bridge were built. The outer 2 were fixed in place and the inner one was free to move on its pile caps. The model bridge sections were made of wood with 50-pound lead weight bricks resting on top of the bridge sections. At first, the still water level was set at an elevation just below the bridge deck. If you look carefully, you can see how waves can damage bridges. The middle bridge section is bumping just a little bit in the down wave direction as each wave passes under the bridge.
Same case, walking the platform back. 3 centimeters shallow with low cord.
The still water level was raised to approximately the same elevation as the model bridge guardrails. You will notice the movement of the spans occurs even with additional weights.
It'll be good enough. It's going with 4 bricks, isn't it?
The model span in this run was bumped to a point that it was eventually knocked off the pile caps. This damage is similar to what has been recorded after Hurricanes Ivan and Katrina. At the very end of this clip, you will notice the span flipping over. This, too, was observed at Biloxi due to Hurricane Katrina.
There she blows!
The implication of these videos, when combined with post-storm damage observations and methods for estimating wave loads on bridge decks, is that the fundamental damage mechanism occurs as the storm surge raises the water level to an elevation where larger waves can strike the bridge superstructure. The individual waves produce both an uplift force and a horizontal force on the deck. The magnitude of the uplift force from the individual waves can exceed the weight of the simple span bridge decks, and the total resultant wave-induced force is able to overcome any additional resistance provided by the typically small connections between the pile caps and the bridge decks. The decks begin to progressively bump or hop or slide or walk across the pile caps in the direction of wave propagation in response to individual waves. This condition can occur before the storm surge elevation exceeds the bridge deck elevation, and the buoyancy of the bridge decks is probably of a secondary influence.
These laboratory experiments are described in a draft report entitled Wave Forces on Bridge Decks. For a copy of the full report, go to this website. The report is a synthesis of existing knowledge related to wave forces on bridge decks. It reviews and interprets relevant research findings, practices, and laboratory studies. It also presents new post-storm damage assessments for bridges damaged recently. The report outlines a method for estimating wave loads on highway bridges that is recommended as an interim guidance until additional research can be completed and brought to practice. The method is simple, can be applied conservatively, and is consistent with the existing coastal engineering research literature, as well as evidence from the recently damaged bridges.